Morning, year 12. Or should I say year 13? How's it going, everybody? Got 3 people waiting on the chat on the website, which is great. How you guys all getting on? So today, guys, we're going to be beginning the process of starting to look at A2 chemistry, which is all very exciting. If everyone can just say, oh, hey, Emma, thanks for coming. It's great to see you. Oh, Ria's online. Sherlyn, do you actually, is this your last lesson? I think it is, right? I think this is Sherlyn's last lesson. Do I have to be here? I'm gonna say, or do you have to be here? Well, I'll put you in on the register, but in reality, I wasn't sure if you were doing AS. I'm doing a recap. We're looking at AS today. We're doing Unit 2 kinetics. I've got Dat, I've got Ria. And so, Sherlyn, you can be here if you like. But in reality, I mean, like, it's not really, you don't really need to be here, I guess. At this point, we're going to be just doing a quick recap of AS kinetics. And next lesson, we're starting true A2 content. So if you want to hang around and be here for the lesson, you're more than welcome. Obviously, I'm going to miss you not being here in the future. Oh, it's going to be sad, Sherlyn. She's not leaving, by the way. Who said that? Ria, is she leaving? She's decided that she doesn't want to take A2 chemistry. She's decided she's going to drop chem. That's why. Who else have I got? I'm still missing loads of people. Missing Jasmine, Kayan, Ben, Ivan, Nikita, Mika, and Dana. So let's see how long it takes before these guys appear. There's Ivan. Yo, Ivan. Starting to get used to people with all their crazy names like Mean Beans. Nikita's in the house. Whoop, whoop. Morning, Nikita. Morning, Ivan. Let's see how long it takes. We're now 1 minute into the lesson. Let's see how long. Oh, there's Kayun. Amazing. Let's see how long it takes Jasmine, Ben, Mika, and Dana to appear. And then I'll crack on. So is it like the title of the webinar suggests? Guys, you can put down in your notes that we're going to be starting Unit 4 chemistry. Now, just to be aware, I will probably be teaching you guys Unit 4 Chem. I will probably be teaching you guys, Unit 4 Chem all the way through now until the end of year 13. With the other class, I'm starting Unit 4, but I probably won't be continuing. I'll probably switch to Unit 5 when we do go back to school. Jasmine's in, Mika's in, fantastic. We're nearly there. Just missing Dana and Ben now. Just Dana and Ben to go. How's everyone coping? Is everyone all okay? I know that it's been a tough few weeks, hasn't it? But at least the lockdown's starting to ease a little bit. Got a feeling that everyone's going to be a lot happier in the next coming weeks as things get a little bit easier. That's the hope anyway. I'd love to be able to go back to school. Fingers crossed. Right, what I'll do is I'll leave it for 1 more minute for Dana and Ben to make an appearance. But otherwise, then we're gonna crack on with our webinar. So the first activity, the first task that I'm going to set you guys to do, let's see if I can pull this up. First task that I'm going to be getting you guys to do is, let's see if I can find the right, there we go. So I'm probably going to be, I've got AS Unit 2, I'll create a new section. A2 Unit 4. A2 Unit 4 is what I'm going to be doing with you guys. And we're starting with kinetics. There's Dana. Ben always tends to be a little bit late, doesn't he? Ben's last again. Okay, I'll leave it at that, and I'll mark Bennett as missing for the time being. I'll close that down. Right, I'll share my screen with you guys. And then click on that one, make everything disappear. There we go. Hide that. Right. Okay, guys. So we're going to be A2 Unit 4 is what we're going to be. So in your notes, you can. Well, I've actually created a sheet on here. Oh, I don't actually do that. I want to just do a title up here. So with you guys, with Miss Childs, you guys are going to be doing Unit 5. Now that actually makes more sense because I've got you guys 3 lessons a week. Miss Childs only has you for 2. Unit 5 is slightly smaller than Unit 4. So it makes sense for me to have slightly more lessons than you guys. So this is technically, we're going to be starting A2 Unit 4. That's what we're going to be starting off with. Unit 4, Module 4, however you want to call it. And we're going to be starting our first topic that we're going to be covering. Yeah, the topic 1 is kinetics. And the great thing, of course, about this is the fact that I have already taught you kinetics in AS Unit 2, which is super handy. It's really, really nice that I've got that. With the other class, I'm also currently doing Unit 4 with them, and I didn't teach them kinetics AS, and I feel like I want to reteach it just to go over it so that I know exactly where they are, but I know that you guys have all this. So I think the first activity which I'd like to do, and I'd love for you guys to be able to contribute onto this. So I'm wondering whether or not, what I'm going to do, I'm just going to quickly create, I'm going to create myself a Google Sheet, a Google Doc. I'm going to share it with all of you guys. I should have kind of pre-prepared this, really, shouldn't I? Because what I just want to do is I just want to do a quick activity on AS Unit 2 kinetics. And I have no idea whether or not I can share this with a class or not. And you guys need to be able to edit it. If I do, it's not going to come up if I do that, is it? I need to create my own actual email group because otherwise I'm going to have to share it with everyone. Okay, I won't bother doing that today. What I'll do is we will stick to this and you guys can just put it on the chat. Okay, so guys, do me a favor. Yeah, AS kinetics. So guys, just really quickly on the chat, please give me as many words for AS kinetics as you can. Go, and I will add them to the heart that is AS kinetics. Give me all your words, folks. Give me all your words for AS kinetics. Let's see how many ones I'm gonna. It'll be interesting to be able to see the difference between the words that you're using from AS and the words that come up from GCSE. Fun, kick-ass, I like it. Yeah, straight away. Can I just point out that that's a really nice thing for everyone to say? Yeah, for me to have 3 people spit out kick-ass straight away, which is great. Yeah, we know that this is the method of answering. And in fact, that's actually going to be enthalpy. Enthalpy is not frequency. Yeah, I like it. I'll put successful calls. I'll put frequency. I like that word. It's good. It's be very interesting to compare it with the other class. Keep going, guys. Give me the others. Come on, as many as you can think of. Doesn't even matter if it's GCSE. Yeah, what other ones can people think of? It's nice for me to, because that actually is the most important one for me to recap with you guys is kick-ass for A2. But I do need all the rest. Come on, guys. Give me more. Thank you, Ria. That's exactly what I need. Maxi B graphs. Yeah, great. Thank you. Excellent. Next, rate. I like it. And even rate equation. Yeah. Rate of reaction. Yeah. I'll put catalyst on there. That's good. I like it. Give me more. Give me more. These are good. Keep going. Activation energy. Like it. EA. Love it. Yeah. Next. Well, hello, Ben. Ben, I'll quickly add you to the register. Temp, like it, thank you. Temp, next. It's interesting, isn't it? Trying to pull all this. Well, hello, boss. Hey, Ben, good to see you, dude. Come on, guys, give me more, give me more, give me more. There's loads more here from AS. Closed system, more equilibrium than rates of reaction. More equilibrium. Don't tend to talk about closed system. Dynamic equilibrium, more equilibrium than kinetics. I'm surprised that I've only had, just to highlight some, temp, catalyst. Yeah, I'm surprised you guys haven't given me the other factors yet. Come on, guys, give me more factors. What factors can affect rate? I'll start giving you a couple of hints, guys. Pressure and concentration, thank you. I love that you put those two together. Yeah, you realize that it's the same in kick-ass. Yeah, these two have similarities. Same kick-ass. Yeah, next. Coughs, equilibrium, surface area. Horrible one, surface area. Yeah, everyone hates kick-ass for surface area. My bad. Love it. Keep going, guys. Give me more. You're doing really well now. What about these guys? I know that they're more energetics, but it does actually make an appearance. Yeah. Can I remember what these are called? It is energetics, but it's actually both. Yeah, it can appear in both because of this bit. Yeah, because of that bit. Whoops, sorry, there you go. Because of that bit. Exo, double hump. Yeah, these are called reaction profiles. Yeah, catalyst. Yeah, other way, exo, endo. Yeah, happy to do exo, endo on there, even though, again, part of energetics, but it's also part of rates. Yeah, it does make an appearance there. I'll put reaction profiles. Anything else? Anybody got anything else? Get rid of all those. Can anyone remember? Now, I know that we've got rate. Can anyone remember what the rate equation is at AS? How do you calculate rate? This one would come off rates, I guess. What about practicals? Does anyone remember any practicals that were really important for rates? Industrial stuff like compromise between rate and equilibrium, more equilibrium than rates, Kayan. Product over time, gradient, thank you. Rate graphs, finally. Yeah, that, guys, that one needs to be emphasized. Took a while, and I'm extrapolating from Ivan. Yeah, changing concentration over time. I like it. Yeah, rate equals change in concentration of product over change in time. I like it. Yeah, 1 over T. Love that. That's really good. 1 over T. Thank you, Jasmine. Great addition. 1 over time. Yeah, that's a great one being rate. Love that. That's really good. Rate equals 1 over time for fixed products. I've got an empty arrow up here, guys. I can always erase it. Has anyone got anything else they want to ask? Rate graphs are one of the key things I need to focus on today. Key things I need to remind you of. Maxi B's, kick-ass. These are the 4 that we really need to focus on. Now, just to explain why. So in A2 rates, there is an entire A2 kinetics. Yeah, the AS stuff is not forgotten. So I know that some of you guys will be drawing the heart in the way that I have. But the only bit that really matters to me is the list of the bits that I know come up at A2 frequently. So we need to make sure that we have solid knowledge and understanding, because without this, it does mean that A2 becomes tricky. Yeah, solid knowledge and understanding of, so we've got number one, we've got, you guys have to be able to run kick-ass for all 5 absorption. That work? I should do measuring rates. It's not one that you talked about. We'll be talking about that later on. But you're thinking more of bond enthalpies, really. I need every single one of you guys to be able to run kick-ass for, this is where I can zoom in. Yeah, kick-ass for, I'm going to draw another one of these. 1, temp. 2, catalysts. 3, pressure. I'm going to put pressure and concentration together since they're the same. 4, surface area. I need you guys to be able to run kick-ass on those. I'll do a couple of revision questions today, just to remind you guys on the ones that everyone forgets and the ones that are most frequently asked today too. The next thing that we need to make sure that everyone can do is max EBs. Yeah, they reappear. A Maxwell-Boltzmann distribution. Maxwell-Boltzmann distribution. I don't know if I've spelled it right. Distribution. There we go. Maxwell-Boltzmann distributions. Got to be able to have those. They come up frequently at A2, especially multiple choice. Next, I need you guys to be able to do rate graphs. Oh, rate graphs. Can I just say, I think everyone hated rate graphs. Yeah, I'm going to do a focus on that again today as well. And we also need to be able to measure the rate. Yeah. And this is practical. I'm actually going to do this one in red. Practical. I know it, by the way, it's hard. I still got stuff I need to work on. I need to create a sheet with all the practicals on it, with example videos and me talking through all the pros and cons and all the questions. It's on my list of things to do. I'll do that next year when we go back to school. I'll get you guys to help me videotape them. Be good. Practical measurement of rate. Now, the way that you guys did this primarily at AS, it's not always. You can do, we can have number 1 is collecting gases. Yeah, gas collection. Number 1. Number 2 is mass change. Mass change. There we go. Those are the 2 main methods that tend to be asked at AS chemistry. You're going to be adding more to this as of A2, but these are the 4 things I want to do. So the first thing I'm going to focus on, guys, is let's do kick-ass first. Right, kick-ass. So for those students who watch the video later who don't know what kick-ass is a method designed by me, designed by Mr. Duncan himself, a method designed by Mr. Duncan, by Mr. D, Mr. Duncan, for a method to explain rate change, due to changes in temp, pressure, surface area, all our jazz again. Yeah, temp, surface area. The method is designed, temp, surface area, pressure. I always put pressure and concentration together because they are the same explanation, yeah, in terms of kick-ass and then catalysts. Yeah. Now this method, kick-ass, is just the way I, but The K stands for knowledge. We know this. Yeah, and that usually comes from this is what do you know about particle? This is particle theory. Yeah, you guys remember all this, don't we? I know you do. Yeah, particle theory. This is collision frequency change. Collision frequency. Collision frequency. This is the number of particles with activation energy. Number of particles with EA. And then this is the number of successful collisions. And I invented this number of successful collisions. I invented this because I realized how many students were answering these in continuous prose and making an absolute meal of it. And this is designed to be able to hit all 4 marks in your explanation. There's usually a 5th mark based on rate. You usually end, it's usually kick-ass followed by rate, question mark. So it can be 5 marks, but it varies between 3 and 5, all those kind of things. So since we're here, year 12, can you all do me a favor? On the chat, please. This is where I'd love to have the online document so I could see you guys answering this in its entirety. Yeah, but I'm going to do question number 1. So I'm going to have Nikita decreases temperature. Explain rate change. Explain rate change. And that there is a 5-mark question in your A-level exam. Now, I know that this is AS. Absolutely. Nikita, you're now famous. You're famous on YouTube. I'm pretty sure you're probably already famous somewhere else, or maybe like Instagram with all your millions of followers. But guys, can you run kick-ass for me? 5 bullet points, nice and short. You can give me the short versions of it. Yeah, just give me the 5 bullet points, please. Run kick-ass for me. Yeah, kick-ass. It's a pirate version with a rate at the end. Kick-ass. Maybe it's kick-ass. No, that doesn't work. Kick-ass. No, that doesn't work. Ben, you need to say what happens to the kinetic energy of the particles. You haven't said it. You need to give more detail. Ben, you need to give the actual answers to this. Yeah, what's going to happen to the kinetic energy? What's going to happen to the collision frequency? Yeah, particles have less. I love this. Dat and Ben are now working side by side. Tag team effort. I love it. Knowledge. Particles. Thank you, Dat and Ben. Temperature decrease, therefore particles have less energy. Particles collide less frequently. Fewer particles have activation energy. Fewer successful collisions, rate decrease. Dana smashes it out the park. There's a minus sign. Oh, nice one, Ben. Dana just absolutely smashed out of the park. All of you guys can just give up now. That was amazing. Thanks, Dana. Dana, I'm going to give you a commendation for that. Oh, that's really funny. Shouldn't laugh. But I love it. Particles. This is your particle theory bit. Particles have less kinetic energy. Yeah, I'm just going to put KE. Less kinetic energy. The collision frequency, therefore, decreases. Collision frequency decrease. Yeah. Fewer particles have activation energy. Fewer parts. Well done, Dana. Smashed it. Commendations. I know, right? Fewer particles. I should be really good at this in case people watch it who don't know what I'm doing. Fewer particles have EA. I'm just going to put EA. You can't do that in an exam, but you never know. Right, and this is a separate mark. This is actually the most lost mark in all of kinetics AS. Yeah, there therefore will be, I shouldn't do that in the exam either. Therefore, there will be fewer successful collisions. Successful collisions will be good. Yeah. Therefore, rate will decrease. We're done. We know this process. We know this well. Yeah. And I don't really think I need to run this for all of them. Well done, Dana. Absolutely nailed it. Let's go for another one. Let's go for another one. By the way, temperature, very common. This there. Yeah, very common at A2. Yeah, they're checking that you haven't forgotten all the theory stuff because it's important. Yeah, let's go for one more. Yeah, let's go for one more. Question number 2. Dana. Let's make it more. By the way, guys, you always know that the difference between GCSE and A-level is there's the idea of how they ask the questions. Dana increases the volume of her reaction vessel. Not wrestle, vessel. Margo, Yorkshire. Dana increased volume of her reaction vessel. What happens to rate? Yeah. Explain rate change. Now, just to tell you that all reactants are gases. Yeah, we could do it like that. I could give you the Haber process if I wish. There we go. There we go. Gas. There we go. Right, guys. Dana increases the volume of her reaction vessel. Explain rate change. Guys, give me kick-ass, please. Run it. Remember, knowledge is about particle theory. And it's actually kick-ass. It's the pirate version. Pressure decrease. Right. Do you know, Emma, that's the hilarious bit. There is no mark for that. That is not the knowledge bit. Yeah, I'm glad that you know that. Now you need to explain what that actual pressure means. Yeah, you need to give me it in particle theory, remember? But you're right. By the way, guys, so Emma has actually just done the hard bit for you. She has made the connection that if you increase a volume, yeah, if you increase a volume, you're going to decrease pressure. Yeah, let's look at how that looks. Here's Dana's reaction vessel. Yeah, here's her 4 particles in that reaction vessel. Yeah, she then increases that size of her vessel. Yeah, the number of particles has remained the same. Yeah, pressure decrease, hence less reactants per volume of space. So collision frequency decreases, less successful collisions rate decrease. Thank you so much. That smashes it. Fewer particles in a given volume. Well done, Vria. There's your knowledge. Well done. Pressure decrease, less particles per unit square, less collisions, less successful collisions, rate decrease. Dana, well done. Great job. Well done. So guys, you know what you're doing. I've taught you well. I have trained you well. Well done. That was great. Yeah? So increase vol means decrease pressure. Still haven't gained a mark yet, but I'm just explaining it. Yeah, increase vol means decrease pressure, means fewer particles. Means fewer particles per unit space. Fewer particles per unit space. Therefore, collision frequency decreases. Yeah. Col freak, yeah, decreases. Therefore, that one doesn't change. I skip the A. Yeah, it's nice for me to talk through those people. Ben, the concentration decreases so that right, you can't say concentration, Ben. You can't use the word concentration in a pressure setting, but they are the same thing. You need to actually say there are fewer particles per unit space. So the collision frequency decreases, which in turn leads to less successful collisions, and the rate decreases. Absolutely. Just change the concentration bit. Your knowledge you would have lost. Yeah, we skip activation energy because the temperature has remained the same. And so therefore, successful collisions, successful cols decreases, therefore rate decreases. I like it. Guys, I have trained you well. No, Ben, that's the whole point of the feedback. It's really good for you to be giving me that because lots of people will be thinking it, and it's nice for me to make that a point as you can't use the word concentration. You must use this particles per unit space. Ben, that's what exactly, you make me a better teacher, Ben. There you go. Right. So I'm pretty sure that most of you are thinking, okay, I'm pretty good at kick-ass. I'm good at the process. I've practiced it. I know it. Right. Let's do our maxi B. Let's do our maxi Bs now, folks. Yeah, maxi Bs. So I'll just move up. There we go. I'm actually going to zoom in. This is our maxi B graphs. I'm just going to put maxi B. Max B. Max bolts graph. Right. Okay. And now I know you guys on the chat, it's going to be tricky. So here is the original line. Yeah, I'm going to do this in green. There we go. Original line is there, right? I'm going to add a new line. I'm reminding you guys of how to do this. Remember, you leave straight from 0 in a straight line until you hit the line. And then I need to make this area. There we go. Shouldn't really do it in multiple lines. There we go. That'll do. Oh, guys, sorry. I'm just quickly getting a phone call. Hang on one sec. Hello. Sorry, folks. Sorry. I have no idea what that was. Sorry, I had somebody call me on my phone. Right, guys, so here's my question to you. With this line, what did I do to the temp? Yeah, for that line, what did I do to the temperature? Off you go. On the chat, please. First person in. What did I do to the temperature? Increased. Ivan's on the increase. Higher. I like it. Increase. Increase. Good job, Tenzi. Only 4 people giving me feedback, folks. This is where I really need our next lesson. I'm going to have an active document that you guys can input on, because that way it'll be more instantaneous. Up, Kayun, what a good up. Love it. Great job. Thanks, Jasmine. Well done. So this one here was at a higher temperature. I like it. So that one's hot. Yeah, raised shouldn't do that. It's actually you just say raised temp. Yeah, thank you guys. Okay, so I think everyone's okay now. Just gonna do this purely. Yeah, if I want to lower the temperature, it goes sharper, higher, and I'm aiming to come down on top of that one and then never touch it again. There we go. And this area here should roughly match this area here, which it just about does. There we go. So it's really important that we're able to do these and we've got these routines in place. Yeah, really, really important. They come up a lot at A2 as well in multiple choice. Definitely worthwhile focusing on them and just doing a quick recap. Okay, so I think everyone's okay with their maxi Bs. Oh, actually, let's do a whole load of other questions just before I finish. Guys, on the chat, please. What is the label for this axis? What is the name of the label for the x-axis? Go. What is the label there for the x-axis? On the chat, please. Go, go, go. See who gets in there first. Oh, I like it. Donna's given me energy in joules. KE. I like it. X-energy. I like it. I love that Donna's given it in joules. It could be in kilojoules. But the units don't really matter all that much. Energy is the key important bit. Yeah, well done, guys. Thank you. Energy. I'll even give Donna's units. Even why not? They don't tend to give units on that, Donna. Go figure. Just don't. Okay. What's the y-axis? Off you go. What is the y-axis? I like Ivan's kinetic energy, by the way. It's actually quite nice, that. What is the y-axis? number of molecules, number of molecules, number of molecules. That's great. Thanks, guys. This is good. I like it. Yeah, it's not the proportion. It is the number. Yeah, this is the number of molecules. Saw that on a couple of papers that students were doing. Number of molecules. Love it. I like it. Yeah. Okay, so what does the total area under the graphs represent? What does the total area under each graph represent? Fraction of molecules with energy. That's thanks, Dat. Ben, are you answering my question or a previous one? Yeah, the answer is that the last one's well done, Dat, well done, Dana, well done, Tenzi. It is the total number of molecules. Yeah, total number of, I'll put particles. Yeah, because it could be atoms, could be molecules. Yeah, but by the way, if you put molecules, that would be fine. You'd get that in your exam, of course it would. Yeah, total number of molecules. I like it. That's why the area under the graph can't change. Yeah, previous. Yeah, Ben, don't use the word fraction. You've got that from, not from me. Yeah, you've got that from somebody else. Don't use the word fraction, Ben. Yeah, it is not a fraction. Yeah, you need to just say the number of particles. Yeah. I'm 30 seconds behind, so that's okay. Okay, next. I'm going to draw a new Maxi B since this one's getting messy. Let's draw a new one. Whoa, don't like that. Don't like that, but it's not bad. There you go, that's better. Okay, guys. So why do some people say percentage or fraction? Yeah. The reason why, Kayan, can you say number of particles for the y-axis? Because I remember seeing on a mark scheme that you can only say number of molecules. Right. Right. The reason why, Dana, was because they gave you an equation which actually had molecules in it. Yeah. Why do some papers say percentage or fraction? Right. Okay. The reason being is because in reality, trying to count molecules would be a bit ridiculous. Yeah. The number of molecules in here is going to be massive. Yeah. But the thing is, it can't run as a percentage. Or fraction. You wouldn't do that because then you couldn't scale the height of it properly. It wouldn't scale properly, would it? If you actually did percentage of the overall. I don't like it. Do you know what? I'd like to see that paper, Kayan. Kayan, if you can find me that paper, I'd like to actually see it. Yeah, I know. It's awkward, that, isn't it? I don't like it. Just letting you know. It's because you can't really count them because there's too many in reality, but they do actually count them. And then a fraction. Because the problem is they're going to be working on it as, it's the way that they actually measure the number of them. Anyway, I don't want to get too lost in this. Guys, that point there. What is that point on the graph? What does that point there represent? What does this point here represent? So I'm going to say A question mark, B, and C is Y start here. Y start at origin. 3 questions, guys, on the chat. A, B, C. You can just put A equals, and then you can give me what you think each one is. B is the mean. I like it. Well done, Dana. A is a most probable energy. Well done is correct, Ria. Great job. That's the mode. Yeah, I like it. A is the most probable. Probable. I love that word. Probable. This is the average. Yeah, the mean. Off to one side. A is the mode most popular. I love that, most popular. A is most popular. B is the mean. C, number of particles with no energy. C, starts up because 0 particles have energy. Thank you, Ivan. You've been doing the papers. Thank you. Jasmine, no particles with no energy. Spot on. Well done, Jasmine. That's great. Well done. 0 particles with 0 energy. Well done. I like it. You guys know your graphs. I like it. I like it. I like it. You can't have 0 energy unless you get to 0 Kelvin. That's correct, and you can never get to 0 Kelvin. Winner. Okay. Maxi B's discussed. Done and discussed. Let's tick it off. I like it. Next, rate graphs. Oh, everyone hates rate graphs. Right, guys. Rate graphs. Right, these are harder. Rate graphs, right? So this is original, Ori. So this is concentration of product. And this is time. Seconds or minutes, whichever one it is. Right, guys, new line. Sorry about the wobbliness. Tried so hard. Hey, so there's new line. A. Guys, what could I have done to cause A? Explain what could have caused A. What caused this change? Now, can I just point out, okay, I like it. Tenzi's given me the number 1 answer, top answer. Yeah, he's gone increased temp. There are others. Adds a catalyst. Well done. Number 2, added a cat. Love it. Meow. Number 3, well done, Kayun. Increased surface area. Love it. Anything else? Increased pressure. Good job. Yeah, we realize that lots of things could have done this. Now, Tenzi, your one you've got to be careful with. Yeah? Increased conc. No. That's not okay, Ivan. Right. So, pressure. Okay. Pressure is a bad answer. Yeah, you can't just simply say pressure. However, I will accept someone if they can actually explain how they've done the pressure, because pressure doesn't work unless you've done it in a very particular method. What about increasing conc but decreasing vol? Right, so you realize, Ivan, you've got to have detail here, don't you? Decrease volume, yes. You can never say the word pressure. It won't be allowed because it's not, it doesn't, there are methods of changing pressure. What you have to say is a decrease in volume, which leads to an increase in pressure. Yeah, because the problem is we know that pressure we can do by adding more gas or reducing the volume to increase it. So this one needs detail. Okay, guys, on to the next one. What about this? Okay, how could I have caused B? Now this one's going to need a bit more. You need multiple factors now, folks. Think about it. Yeah, think about it. How has he caused that one? Increased temp, but halving the reactants. Okay. Okay. Yes, you've genuinely changed too. Yeah, you're right. Decreased conc, but increased temp. No, you're definitely wrong, Dana. Increase temp and halve the reactants. Tenzi is correct. Yeah, you could do that. You could do B with an increase in temp and half reactants. But the problem is you're halving the reactants you need to be careful of, because you'd lose it for that, halving reactants. That one, you've just lost the mark because that's not correct. That one is correct. The temperature, I'm going to highlight in yellow, is going to cause the increase in rate. It's going to cause that bit. Now, Tenzi did something clever by then saying if I halve the reactants, because I've made half the original. However, the problem is he's not given enough detail to get the mark. Adds a catalyst but decreases vol. Again, you've got to be careful on your wording now, guys. Decrease conc but increase temp. Decrease conc. No, you definitely can't say that, Dana. Dana's definitely not right. If you decrease conc, the rate would slow down. If you increase temp, you'd raise it back up and it might even balance out. You wouldn't know the exact factors that would be causing it. But you do have to be isn't halving reactants decrease concentration? Exactly. But no, it's not. Right, that's the point, Dana. This isn't clear. You'll lose marks here because it is unclear. Because if you just say halve reactants, it looks like undear. Yeah, unclear. You could argue that that says half the concentration. Can't do that. Yeah. What you need to say here is almost go all the way and say increase temp. Yeah, increase temp. Conc same. Conc same. Vol of solution. Vol of solution halved. Yeah. You can't say half reactants. Yeah, halve the volume. Yeah. So all of these things are clever, and they do this, folks. Yeah, these graphs are an absolute nightmare, and they need practice. I ought to make a booklet of all of the ones that have happened over the years because they are hard, and you have to sketch them, and it's tough. Yeah, I will put together, I will work on creating that as a resource. Someone needs to remind me. Okay, so we've had a quick discussion of rate graphs. Next thing is practical measurements. So we've been doing practicals in chemistry. I know that we haven't recently because we've been online, but you did do this for rates. Common pracs that we need to make sure we know. Pracs to know from AS and technically GCSE as well. GCSE. Pracs to know. HCl thiosulfate. God, comes up so often. Thiosulfate. That's the beaker that turns cloudy with the cross. Everyone probably remembers that one. Beaker that turns cloudy with the cross underneath it. And it goes cloudy and you have to watch it. Yeah, do everyone remember that one? Yeah, and that one, of course, is an appearance. And this is almost Ben's absorption one. Can I just point out, we don't do this anymore. But you do need to know it. Your timing, how long it takes to disappear till it turns opaque. Because you make solid sulfur, by the way, in that equation. You also need to know magnesium and acid. I'm tempted, I'll just put HCl, but you could do sulfuric, although not particularly good. But you can. And sulfuric acid would work. Nitric acid also works. This one, of course, is usually a mass change. Yeah, this is a conical flask. Ooh. This is a conical flask on a weighing scale. Yeah. And you're watching the mass change, and you have to add cotton wool to it. Yeah, because it makes gas, makes hydrogen. Yeah, and the mass decreases. Yeah, the other one, of course, that you guys come across is gas collection. Yeah, is collecting in a gas syringe. But that one is related to that one, I guess. You can also do the same argument for that one. Right now, guys, what I'm going to do is, when do I have you guys next? Oh, we've got got ages away. So that actually brings me to the end. That actually brings me to the end of your kinetics recap. I'm not going to focus too much on that. I'm just going to go back to here. Hey, guys. So we've just done a really quick recap of little bits to think about. What I'm going to do is, I know that you guys have got access to the sheet I created with all of the booklets. I would really, really like you guys to have a go. And do you know what I'm actually going to do? Actually, I've changed my mind. What I'm going to do is I'm going to make you a Google form test. I'm going to make you a kinetics test on Google form. And on kinetics, so I want you to do some revision over this weekend, because our next lesson on Monday is on Monday. Is it on Monday? Our next lesson is next lesson's Monday. No, Monday, we're off. Amazing. Next lesson is a week today. Guys, I'd like you, please, to do some revision on kinetics from AS, and I'm going to be giving you a Google form test, only 20 questions, just for you guys to be getting back into the swing of things. There's no point in me jumping headlong into A2 kinetics if we haven't made sure that all of that is down. I'm going to be picking all of the multiple choice based on kinetics from AS. Guys, Tuesday. No, I don't have you on Tuesday. I don't have you guys on Tuesday. I've got you guys Monday, Wednesday, and Thursday, and we're off Thursday, Friday, Monday, so the next one is a week today. So just do a bit of revision, guys, over the coming week. And as I said, I'll send you out the Google form test to have a go at. I'd quite like to do it. I don't really care about it being a test, to be fair and done. I might send it, when I've made it, I'll send it out and you guys can just submit your answers over the weekend. I don't want you guys to feel like I'm hammering you already with like homeworks and whatnot. But as I said, I just need to make sure that everything is boxed off from AS before we start A2. Guys, go and have a nice rest of your day, and I'll see you guys soon. Take care. See you later, guys.